as long as we are able to build a system, it could be an abstraction that makes it easy for our users, and as long as it solves the problem, that's good. I've noticed time and again that simple systems scale better. Any kind of like clever, complex code, ultimately in the long run, although if the overall architecture is simple to explain to others, well, it will stand the test of time.
Hello, I am Adi Polak, and you're listening to Confluent Developer, where we explore the fascinating journeys of software developer tackling complex problems. In this episode, I'm interviewing Aravind Suresh from his early days exploring distributed systems to becoming a key figure behind OpenAI real-time infrastructure. Aravind shares a story of scale, simplicity, and building the right abstractions for AI. His early passion for coding, starting back in school, eventually led him into the world of data streaming, large scale systems, and enterprise software. So, what did OpenAI do differently to scale their data streaming platform? Have a listen. Hi, Aravind. I'm so excited to have you on our show.
Hi, Adi. Excited to be here. Nice to meet you.
Yeah, well, thank you. First of all, thank you so much for being part of Current NOLA program committee. Your insights and comments were fantastic and really helped us build, a good program. And also, thank you for being a speaker and sharing your expertise. I know, behind the scenes, there's a lot of work that you put into actually taking everything that you know and turning it into a presentation that people can learn from. So thank you for doing all these great things for the community.
Yeah, thank you. Excited to share our learnings as we like whatever we have done at OpenAI. So it was fun being part of the conference.
That's fun. So I definitely know you. A lot of our program committee and maybe some of the folks from Corinth knows you,
Mhm.
but not everyone who are listening to us today do. So maybe you want to share a little bit about yourself.
Sure. Yes. I'm Aravind. I'm currently at OpenAI. I lead the real-time infrastructure team. So we power the streaming backbone behind all AI products like ChatGPT, Sora. We also help a bunch of research workflows too. So I've been doing distributed systems and data platform for like close to 8 years now, and I've been like I found this space sometime. I can tell you about that in a bit, but like there was a moment in my life when I figured out that distributed systems was something that I was really passionate about, and I've been like diving deeper, building systems that scale pretty much my entire career.
That's amazing. I mean, there's so much to know about distributed systems. I always feel like it's it's a whole world that when you start digging into it, when you're a user of a distributed system, let's say you're a consumer of an API, it's one angle. You try to optimize, you have a product mindset.
Mm.
But then when you dive deeper into the infrastructure, it's like, oh, things are not consistent. What do you do?
Yeah, exactly. Like I think this is a good point about infra and product, right? Like I've been part of infrastructure teams pretty much my entire career, and it has always been I like working with product teams or like different teams in the company because ultimately we are here to build the foundations that make products successful. So we're co-building infrastructure with you. So in early stages of the team or the company, you end up co-building your infrastructure with the product team, and the product teams will be co-building infrastructure and their products with you. So I really like that experience. That is more fun, understanding their use case, partnering where we can help.
That's amazing. So I know you have many years experience with data streaming and kind of data streaming is a big passion and the professionalism, career that you
Yes.
chose. I'm curious, like, what are some of the challenges that you've seen throughout your careers that, and learnings that our people can learn from you?
Sure. So let me start with like my recent experience at OpenAI. So the challenge here was basically how do you build a reliable streaming platform when you're scaling 10x every 6 7 months? So your platform scales 10x every 6 7 months, different sets of use cases, different shapes of workloads that we support. Now, how do you make sure the platform is also reliable when we do all of this, right? The core challenges involve something like balancing velocity and stability with like such a small team, and how do you work with users, how do you hide all the infrastructure complexities. So that just to give some context about OpenAI's use cases, right? The streaming infra is kind of at the heart of OpenAI in like different workflows. Like one of the core things that we use stream infra for is something called flywheel. What that means is um, we build great AI models, then we launch products using those AI models, then you get some usage data about that product based on how our users use their products. And insights from these are actually used to build better models later. And this kind of loop keeps spinning. Like you have more models, you get better usage data, then you get insights, you train better models, and so on and so forth. And guess what? The data pipe here is Kafka. So Kafka is used to store all of these events, and you use Flink and a lot of stream processing to get all of this data as real time as possible wherever it's needed, right? And also in all distributed system setting, let's say experimentation is heavily distributed today. So our researchers and engineers would like to know the latest status of an experiment and see whether it makes sense to continue that or not. And today's training is heavily distributed, right? So you have workers talking to each other, and Kafka is the data pipe to carry those events, and Flink is used to transform and join that to basically understand what to do. It's kind of bread and butter of researchers and engineers. And I've seen this in action. Like without streaming infra, it was very hard for them to build things. With stream infra, it was actually easier for them to do their day to day. So in this background, this is basically kind of the result, right? But this is not how it was when I joined the company. And it was like early stages. It was still a scrappy piece of infrastructure. Like there was no standardization around Kafka clusters at that point. Like there was no blessed paths. Kafka was a single point of failure. And there was a lot of friction and confusion on like how to use Kafka. So this is the state there, and like it was like close to a year or 2 years of work to get us to this shape.
Wow. So let me see, collect all the pieces of information. Essentially, when anyone in the world decides to use OpenAI models, we as humans can give some sort of feedback, like thumbs up, thumbs down, or have some sentiment to what we do. If we're happy, not happy, asking for improvements, and so on. And that essentially becomes a feedback for retraining or rebuilding the models and improving them, so the whole system can become better. And that's as a feedback turns into Kafka events that are being processed later on with Flink in a streaming engine in real time. And that's kind of like the backbone for everything that you do. And then throughout, as you have these data streaming pipelines, essentially it's not serving only that feedback loop with the model, but actually, also researchers today that want to run different experimentation, or anyone who, wants to tap into what is happening in the system needs to have access to that real-time data, essentially, right?
Yes, that is correct. Yes.
Got it. And then your team has to manage the cluster, right? Manage the large scale of this distributed system. I'm guessing that means a lot of machines, and then make sure it runs with the right latency for the system, right?
Yes, that is correct. The emphasis on reliability is actually very high because all of this is mission critical data. It's important to us. So we promise close to 4.5 nines of Kafka availability, and also the core principle behind all of this was building reliable systems was of course important, but another key principle that we kept in mind is how do we make all of this easy for our users to use. Because when I say users, so we are an infra team. When I say users, I talk about all the other employees, engineers, researchers at OpenAI who would use all of this. So how do we make that experience easy for them? So the ergonomics part was very important. It was like building AGI and building AI systems is hard in its own way. People did not want to become Kafka experts, right? So how do we build the right abstractions? We made some early decisions. Like for instance, instead of exposing Kafka clusters directly to users, we built a layers of abstraction. So we built a bunch of proxies surrounding our Kafka clusters so that we can abstract Kafka away from our users. It helps us to do a lot of operations, scalability. It also helps in multiplex. So our Kafka topology is like Kafka messages get multiplexed across different clusters in different regions. And that helps in higher availability. That way, Kafka would not be a single point of failure. It does have some trade-offs here and there, but happy to add details there. But this actually simplified uh, consumption of Kafka and like building workloads on top of Kafka easier for our users. Because tomorrow we can scale a cluster, we can add more nodes, we can rebalance them, we can move them from one region to the other. But having a layer of indirection in between actually helped us it made those operations easier.
Got it. So if essentially, just to see if I understand correctly, different people in the organization, these are our users, different people has
Yes.
different skills and different expertise. Like ML researchers, they have, probably the best knowledge on how to build algorithm and how to improve them and so on. And they have knowledge of the tools that they're using, but we can't really ask them to learn everything about Flink and Kafka. And so we want to give them tools that are intuitive to what they do by building a layer that abstract away Kafka and
Yes.
Flink complexities so they can run faster. That's
Yes.
it, right?
Yes.
Okay, got it.
Yes.
And what are some of the challenges that you ran into? Because I can imagine, people would have all kinds of requests.
Yes. Yeah, that's a good question. So our challenges here was mainly around Kafka being a single point of failure, but that's actually a very hard problem. Like if you deploy, let's say, Kafka clusters in a single region, and how do you make that work in a multi-region setup, right? Like either you can go down the path of having stretch clusters, which I've seen in some cases, where you have Kafka itself distributed across regions. There are obviously latency considerations, stability at scale considerations here. There are some other designs I've seen where you have mirroring from one Kafka cluster to the other so that in case a region goes down. So we were solving about cases where even in the cases where regions were going down, we still wanted Kafka to be up. So even in those cases, we basically had like a bunch of these design options, which were all kind of complex. And we didn't know, we were thinking whether to do stretch clusters or whether to do mirroring. And that's when we decided, can we just make some simplifications here? We thought about okay, we can build layers of abstractions in between, and let's say you multiplex messages from one topic across multiple Kafka clusters. And when we do that, you obviously throw out some notions of like partitioning, ordering, which are kind of very, very important. Like for folks who come from a traditional Kafka world, they would be surprised. They would find it odd that we threw away these core primitives that Kafka became famous for, like partitioning, ordering. But we realized that a majority of use cases were okay with not having those guarantees. They were okay with, let's say, for partitioning, they were okay with doing that downstream, let's say in the Flink app or the downstream consumer. And ordering, as you know, is a hard problem in distributed systems itself, right? So instead of relying on reliable ordering of events, why can't you just stamp your events with a logical clock and use that to sort in the downstream? So we made a bunch of these key trade-offs, and we went back to our users and talked to them if all these things make sense to them, and they were okay with it. And that's when we actually went and built our first version of Kafka at OpenAI. It was basically a producer side proxy which multiplexes messages across multiple clusters, which again, there is a consumer side proxy which pulls all of this for you and sends it to your end consumer services. So this was our first version. This came in sometime around mid 2024.
Amazing. So essentially, you took a lot of complexities out of Kafka and some a lot of failure guarantees, we'll say. So
Yes.
it's probably, coming. I'm sure, like the person that came up with that idea was everyone looked at it and was like, "Who are you? Do you know Kafka?" But apparently, it works because at the end of the day, you're serving a users, and these users are okay with these trade-offs.
Now, a quick word from our sponsor. Confluent Developer, the podcast, is brought to you by Confluent Developer, the website, which has everything you need as a developer of data streaming systems. And it's completely free. We've got curriculum, hands-on exercises, executable tutorials, the online data streaming engineer certification, also free, a way to find a meetup near you, those are free. Everything is there. I really want you to be successful in your journey as a data streaming engineer, and this is the site that has what you need. Check it out at developer.confluent.io. That's developer.confluent.io. Now back to the show.
It definitely shows like a flexible mindset of an engineering, because many times in our career, and my background is also in distributed system infrastructure. There's like the things that we're used to do the way we forever did things, and being user obsessed is definitely a value that can help us build systems that cater to our users versus trying to answer all the best practices in the world. I'll put it that way.
Yes.
So that's exciting. I mean, that's a big learning.
Yeah, I totally agree with what you said, right? Like, ultimately, we are building systems that solve problems. It doesn't matter whether we use Kafka or a database or whatever tools under the hood. As long as we are able to build a system, it could be an abstraction that makes it easy for our users to use that system. And as long as it solves a problem, that's good.
Right, right, right. No, at the end of that's what we're paid to do, right? Solve the problem. So
Yes.
I love it. Cool. Well, thank you for sharing. That's really exciting. I know you build more things, right?
Yes, we built. So immediately after we shipped this, there were more. This solved all the stateless consumption from Kafka, and then after that, there were use cases around stateful processing. So that's when like we started adopting Flink more at OpenAI. Yeah, and also the some of the problems are similar across both. Like, how do we make sure Flink apps scale? How do we make sure Flink works seamlessly with this multi-cluster Kafka? Like, it's a different topology, right? If you have Flink working with a single Kafka cluster, everyone has been doing that for years. But how would you make it work with multiple Kafka clusters? How do you had to build a custom Flink source for it to work? Then you had to build a custom Flink sink. Then we had to invest in control planes because it's only a matter of time. This is also something that I observed in the last year or so. It's only a matter of time until the system that you build, which is horizontally scalable, after a year or so, you end up with like a lot of clusters, a large fleet of clusters for you to manage, and it ends up with a lot of operational toil, on-call pages, etc. Which is when you realize the importance of control planes and importance of self-healing systems, auto-healing systems, and that's kind of where we went next. So we introduced control planes for all parts of our infrastructure, including Kafka, our consumer side of Kafka, Flink. All of these systems ended up having control planes just to manage the scale of clusters that we are dealing.
Yeah, that's smart. It's from a certain scale you have to have it. I remember back, well, it was when I was in Microsoft some years back, but it was post acquisition of LinkedIn. They were building different Hadoop clusters, and then there was a control plane that managed a couple of hundreds or thousands of mini Hadoop clusters just to support the scale. And yeah, I believe today it's cell architecture, which is highly used. This is what we have in Confluent. We call it the Cora engine. There is a paper out there, but essentially we build cell architecture so we can support as many Kafka clusters as needed.
Oh, I see. What is a cell here?
So the cell architecture is essentially can be a collection of a Kafka cluster that supports a collection of things in it. So you can read about the article. It requires looking at the architecture, but essentially this is how AWS, for example, build S3. So this is the architecture behind that. So it's a multi-tenancy environment that takes care of scaling, security, and a lot of other aspects. And that was a great, especially in the recent outage that was, Confluent stayed up which is important because you don't want to put everything in
Exactly.
on one region. You want to continue supporting your users. So I'm very happy you're building a control plane and you have different control planes for what you're doing. And I'm curious because adding Flink is something that you have to think about. Like how do you simplify Flink for the rest of the organization?
Yeah, so it started off with building the right. So ultimately, yeah, rightly said, Flink has its own complexities. Like it has its own learning curve, right? It's not as easy. Like it's easy to talk to Kafka and publish messages, but it's not so easy to write a Flink app. So it started off with us working closely with users to explain Flink semantics to them and building it. So most of the projects that ended up having complex Flink apps ended up like a lot of co-building with users, like working closely with them. But from an infra perspective, what we did is we made sure the Flink control plane handles all of the complexities around deployments, failovers, rolling back clusters, etc. Like rolling back deployments that didn't work, etc. And on the user side, we made it very easy for them to actually create a Flink app. So we had like toolings that can generate all the boilerplate for you so that it's easy for users to actually just latch onto a Kafka topic and consume stream of data from that and write Flinks. And yeah, go ahead.
So if I'm a user and I want to create a Flink app, but I know nothing about Flink, um, do I need to use Python or Java, or do I have any specific requirements of how I write my code? Or there's no code at all, maybe I can ask ChatGPT to generate the code for me.
That's a good question. So we are getting there. So right now, what we do is, so we adopt OpenAI's heavily. A lot of services are in Python. So we also adopted PyFlink. So the initial version of this was good amount of scaffolded code that helps users to write Flink apps. The second version of it, which we are kind of going through right now, is giving users better tools to understand their Flink jobs. Like for instance, coming up with giving tools for them to understand a health score behind their Flink app, whether they are following all the best practices, and giving them a score like 80 out of 100. You're losing 20 points because of this, and these are things that you need to do, etc. Like you're managing your state. And another thing we noticed that we are currently doing is our Flink state for some of these jobs are becoming very massive. And when our users end up debugging these apps, they need to look into their state and inspect. And actually, it's a very big challenge because once your app, if you want to debug your app, you need to look into the state. And without looking into the state, you're kind of blocked. And most of these times, these states files are very massive and they're stored in blob store. So we are currently building a state file inspection tool. So basically, you can debug, look at all the state that's managed by your Flink app, trying to understand what's going wrong, how to optimize things further. Some of these, even subtle bugs in your code, end up creating giant state files, even though you don't intend to, right? The next version of this is some kind of a managed no-code platform, as you said, where we believe in the long term, majority of Flink apps can be represented through SQL or Flink SQL or a DSL. So we're trying to carve the structure of that DSL out and have like a managed platform where users can just give in a SQL or just codify their app in a DSL, transformations, joins, aggregations in a format. And then we manage the life cycle of the app behind the scenes. So this is the no code vision that we have. We can also integrate AI into it. You can have prompt engineering, like you can use natural language to define your Flink app DSL, and then you hit deploy and it gets deployed.
Got it. Got it. So if let's say I'm on the engineering side, but I'm on more on the product side, I will be able to write a SQL and also have all the tools to inspect what is happening in my platform in case performance is not what I want. I want to improve it, so I'll be able to actually have that access to the data. That's really interesting because one of the greatest challenges with Flink is state management, and so many people get it wrong for good reasons because you have to know so many things in order to make the right decisions, and it's just again like we cannot expect everyone to know that. So that's really exciting, and the fact that you're using Python as well with Flink, is the infrastructure also in Python, or do you have the infrastructure side in more of Java world, JVM?
Yeah, so our infrastructure, at least for data platform, all of infrastructure is mostly in Java, but the end user abstractions are in Python. So Kafka client is in Python.
Oh, got it. Got it. Cool. All right. So it's yeah, it's how if there's an error that comes from the Java's JVM stack, like how do you make sure the user can understand that? There's I'm sure you kind of you have the tools and you think through that, but that's always one of the challenges. Like let's say I never touched anything related to JVM in my life, only did Python, which is not true. I was heavy in the JVM space, but let's pretend for a second. I wouldn't know what to do with a Java exception if I'll get it.
Yeah, so actually, we have faced a problem even before that. Sometimes we noticed the actual error inside your Flink app could be multiple layers deep, could be in some different file, some different place. And we once we faced enough problems of this shape, we prioritized a work stream to basically build a UI that can just tell you exactly if there is a Flink app failure. This is what. So basically, debugging your Flink apps, getting the right exceptions, and also we are trying to go ahead with we built an AI agent that looks into these exceptions, and with enough context about your app, it will kind of tell you what the right next steps are and what you should do. And you can keep there's a feedback loop here, because if it doesn't work, users give us feedback, and then we try to fix the agent. But this is also something that we built.
That's awesome. I love the usage of AI to assist in engineering work.
Yeah, I've seen like multiple examples. Like I think Flink AI agent debugger is one example. AI assisted Flink app creation through a custom DSL. That's like another example. Yeah, I'm seeing a lot of examples these days, making us more productive.
Yes, 100%. It's I see it how it improves everything that we work on, and even it's kind of like having a buddy tells you, it's like, hey, here and there you should take a look because it might be that the error is here are three potential reasons why you got this error. Start exploring rather than individual trying to figure it out on their own. So it helps bring the collective brains of everyone in the company to solve a problem without getting everyone involved necessarily in a meeting or in a gathering of other Slack or other tools. So it's this is great. This is great. So you've been working. You've been solving a lot of problems there.
Yeah, every day is exciting, a lot of scale, and a lot of different shapes of problems too. So as I said before, like solving problems with the users, because every and trying to find the right abstractions that would actually generalize to to different use case shapes. It's kind of what I do on a daily basis.
That's awesome. So if you would, to give your younger self or someone that you mentored that now is entering engineering, just, finish their degree or want to enter the data streaming world, what would you tell them?
That's a good question. Couple of things. One is, I've noticed time and again that simple systems scale better. You could have different notions of any kind of like clever complex code, but ultimately in the long run, although if the overall architecture is simple to explain to others, if only if that system is simple, it will stand the test of time. Learned this the hard way a couple of times. And the other thing is, you could the long term reliability actually comes from like a lot of automation. This goes back to the control planes point which I made earlier. Your initial wins in reliability could just come from a nicely designed stack, but in the long term, you would You would notice a lot of manual operations. You would a lot of routine operations, rebalancing clusters, provisioning them, and so the long-term reliability would just come from automation. So building control planes, self-healing systems. So these are some lessons that I learned. But understanding details behind every system was actually important. It's actually more important to understand what it is for and what it is not for, and getting that clarity, because that is how you build the right building blocks for which other users can use and build great systems.
Love it. Love it. So simplicity, understanding the building blocks behind things, and building what's necessary. So sometimes you don't have to over engineer a solution. Arvind, thank you so much for sharing the different things that you work on and sharing your knowledge and expertise. It was super exciting. And yeah, I'm sure people would have lots of takeaways from these.
Yeah, thank you. I mean, nice chatting with you.